This is a bitmap index. A bitmap index uses a lot less space than a B-tree index. However, in terms of subjecting bitmap indexes to large amounts of heavy update activity over long periods of time, bitmap indexes are not nearly as efficient when being subjected to constant changes as a B-tree index is. A B-tree index is the most commonly used index. Commonly, all OLTP databases contain 99% B-tree indexes and very rarely use bitmaps unless the bitmaps are continually updated. There is one slight problem with the bitmaps: you can't update it online. You can't alter index, rebuild bitmap index online. You actually have to shut down access to the index and recreate, or risk SQL code accessing the bitmap index and only reading half the index or none of the index, therefore unable to find rows. Risky, but very, very fast as long as you keep them updated. The simple structure of this bitmap index here is that the bitmap is keyed on this column here. M for male and F for female. M's are always 1, F's are always 0. So you can see that the structure of the index is much less complex than a B-tree and effectively a lot faster to read through, assuming that these values have what Oracle calls low cardinality, or mathematically is low cardinality. What low cardinality means is that it has very few values within this particular column, very few distinct values in relation to the total number of rows in the table. Bitmap indexes have been successfully used with as much as 1,000 different values in a table. Obviously that applies to a very large table. An index organized table is effectively a B-tree index created with the whole table, not just the index columns but the tables as well. The disadvantage of index organized tables over B-trees is that not as many rows are packed into a single block, although this can actually be an advantage sometimes. In environments where there's very high concurrency, access of far too many users to the same block in an index at the same time can actually cause locking issues and latch problems, and wait events occur for different users waiting to access the same block. Index organized tables have been used relatively successfully even in OLTP databases. Special types of indexes with partitions are local and global. Quite simply put, a local partition index applies to an individual partition. In other words, a local index applied to the partition key, the way in which the partitions are broken up. Each partition has a separate local index. Global indexes for partitions apply to all partitions for a specific table. Obviously, there can be problems with global indexes. If you were to drop a partition within a table, the global index is invalid. It's a lot more difficult to maintain global indexes than local partition indexes, depending on your environment and application activity. A cluster simply takes either just the index values or the index values and commonly accessed values and places them into a physical chunk, making it easier to access. Clusters are most commonly used in data warehouse databases and not in OLTP type databases because they're very slow to update and they can overflow very easily, much like the relationship between bitmap and B-tree indexes. B-tree indexes are very fast to update and very efficient, and they do deteriorate over time, but not nearly as much as a bitmap or a cluster. Clusters are commonly used to pre-construct physical joins for tables. In other words, a cluster is an object where you go and copy or effectively duplicate certain columns from a join between two tables, in other words, columns from both tables, and plot them in the cluster. And then when you read a table or the cluster, you read from the cluster first. If it needs to access columns outside the cluster, it reads the cluster and the table. The point is the cluster is physically organized in the order in which the join is required, the SQL code join. Materialized view is unlike a view, which will always execute contained SQL code every time the view is accessed. A materialized view is similar to a cluster in that it is physically pre-constructed. In other words, when you access a materialized view, you're actually accessing the physical data in the materialized view, unlike a view which accesses data in tables contained within those views. Using materialized views to access data is much faster than using regular views because the SQL code is not re-executed. Typically, materialized views are read-only objects. They're commonly used in replication environments and in data warehouses. A partition is a special type of object where parts of tables are split into separate physical pieces that can be accessed individually or as groups of partitions within a larger group of partitions.